Picture this. Right now, somewhere in the cosmic darkness, a new world is being born. Not in billions of years, not in some distant future, but happening as we speak. Scientists have just witnessed something that's never been seen before in human history. For the first time ever, astronomers have caught the exact moment when a planet begins to form around a young star. This isn't just another discovery. This is watching the universe create itself in real time, and it's happening in a system called HOPS 315. Now, you might think we've seen planet formation before, right? We've found thousands of exoplanets. We understand how planets form. But here's what will blow your mind. We've never actually witnessed the very first moment when solid matter starts clumping together. Until now, every single planet we've discovered has been fully formed, already billions of years old. It's like studying adult humans but never seeing a baby being born. We knew it happened, but we'd never seen it actually occur. But I'm about to show you something that changes everything. Using the most advanced telescopes in human history, scientists have finally captured the cosmic equivalent of a birth certificate, and what they found proves our solar system isn't unique. This discovery comes from a team led by Dr. Melissa McClure at Leiden University, and what they've found is so extraordinary that it's rewriting our understanding of how planets form. They've detected the exact chemical signature of the first solid building blocks. In the next few minutes, I'll show you exactly what they found, why it's never been seen before, and how this discovery proves that planet formation is happening right now in ways we never imagined. Trust me, this will change how you see our place in the universe. So buckle up, because we're about to witness the birth of worlds, and by the end of this video, you'll understand why this moment represents one of the most important discoveries in modern astronomy. Let's dive into this cosmic miracle. The HOPS 3115 system sits 1,300 light-years away from Earth, nestled in a region where new stars are actively forming. This isn't just any ordinary star system. It's what astronomers call a baby solar system, only a few 100,000 years old. To put this in perspective, when our own solar system was this young, the planets we know today didn't exist yet. Earth, Mars, Jupiter, none of them had formed. This system is showing us what our cosmic neighborhood looked like 4.6 billion years ago. The star at the center of HOPS 3115 is remarkably similar to our Sun, but it's surrounded by something spectacular, a massive disk of gas and dust called a protoplanetary disk. This disk is where planets are born. Think of it as cosmic clay, swirling around the young star, waiting to be shaped into worlds. The disk contains all the raw materials needed for planet formation: hydrogen, helium, heavier elements, and most importantly, tiny grains of dust and ice. But here's the challenge that has frustrated astronomers for decades. These disks are incredibly difficult to study. The processes happening inside them occur over millions of years, far too slow for human observation, or so we thought. Previous telescopes could see these disks, but they couldn't penetrate deep enough to detect the chemical signatures of planet formation. We could see the cosmic kitchen, but we couldn't observe the cooking process actually happening. That's exactly what makes this discovery so revolutionary. For the first time, scientists have detected silicon monoxide, SiO, in its crystalline form within a protoplanetary disk, and this changes everything we know about planetary birth. You might wonder, why is silicon monoxide so important? Well, SiO is literally the first solid building block of rocky planets. It's the cosmic equivalent of the first brick in a house. Everything else builds from here. In our own solar system, we find SiO in ancient meteorites that date back to the very formation of our planets. These meteorites are like time capsules, preserving the original materials that formed Earth, Mars, and all the rocky worlds. But detecting SiO formation in another star system required something unprecedented: the combined power of the James Webb Space Telescope and the ALMA Radio Telescope Array. This represents the most advanced astronomical observation ever attempted. The James Webb Telescope provided infrared vision to peer through the dust, while ALMA's radio arrays detected the precise chemical signatures. Together, they created a window into processes that were previously invisible to human science. What they found was extraordinary: SiO existing in two states simultaneously, as a gas and as solid crystals. This is the smoking gun evidence that we're witnessing the exact moment when gas condenses into the first solid particles of a future planet. The location of this SiO formation is equally important. It's occurring in the same region where we would expect to find the asteroid belt in our solar system, suggesting that planet formation follows universal patterns across the galaxy. This means that 4.6 billion years ago, our own solar system went through this exact same process. The silicon monoxide that's forming in HOPS 3115 right now is identical to the materials that eventually became the building blocks of Earth. But the discovery goes even deeper. The team found that the SiO crystals are forming in a specific temperature range and under precise conditions, giving us a recipe for planet formation that applies throughout the universe. This discovery proves that planet formation isn't a rare accident. It's a fundamental process that happens wherever the right conditions exist. Every star system with a protoplanetary disk is potentially a planet factory, churning out new worlds. The implications are staggering when you consider that astronomers have now cataloged over 5,000 exoplanets. Each one of these worlds began exactly like what we're seeing in HOPS 3115, as tiny crystals of silicon monoxide condensing in cosmic dust. Dr. Merrill Van Hoof from Purdue University perfectly captured the significance. It's like we're seeing a baby photo of our solar system. This isn't just an observation, it's a time machine showing us our cosmic origins. The detection process itself was incredibly challenging. SiO signals are extremely faint, requiring hundreds of hours of observation time and advanced computer processing to extract the chemical signatures from cosmic noise. The breakthrough came when the team noticed something unusual in the infrared spectrum. There was a specific wavelength of light that could only be produced by silicon monoxide crystals forming in high-temperature conditions. This wavelength had never been detected in another star system before. It's like finding a specific fingerprint that proves beyond doubt that planetary building blocks are actively forming in real time. The temperature conditions where this SiO formation occurs are extreme, around 1,000 degrees Celsius. This is hot enough to melt copper, yet it's the perfect temperature for silicon monoxide to condense from gas into solid crystals. What's remarkable is that these same temperature conditions existed in our early solar system. The region where Earth formed was once this hot, with silicon monoxide crystals condensing and clumping together to form the first planetesimals. Planetesimals are the next step in planet formation, small rocky bodies that serve as the building blocks for larger planets. They're like cosmic snowballs, except instead of snow, they're made of rock and metal. In our solar system, many of these planetesimals still exist today as asteroids and comets. Every time you see a shooting star, you're watching one of these ancient building blocks burning up in our atmosphere. The HOPS 315 system is showing us this process in action. Those SiO crystals will eventually clump together, forming larger and larger objects until they become asteroids and then potentially rocky planets like Earth. The timeline for this process is mind-boggling. It takes millions of years for these tiny crystals to grow into planet-sized objects, yet we're witnessing the very first moments of this incredible transformation. This discovery also helps solve a long-standing mystery in planetary science. Scientists have wondered why rocky planets seem to form in similar ways across different star systems, and now we have the answer. The universal presence of silicon monoxide in protoplanetary disks means that rocky planet formation follows the same fundamental physical laws everywhere. Chemistry and physics work the same way whether you're in our solar system or 1,300 light-years away. But there's another fascinating aspect to this discovery. The team found that SiO formation is happening much faster than theoretical models predicted, suggesting that planet formation might be more efficient than we thought. This efficiency means that planets could form in younger star systems than previously believed. The universe might be more capable of creating habitable worlds than we ever imagined, potentially increasing the chances of finding life. The detection technique used for this discovery is revolutionary in itself. By combining infrared and radio observations, astronomers have created a new tool for studying planet formation that can be applied to hundreds of other star systems. Already, follow-up observations are planned for dozens of other young star systems. Scientists want to see if SiO formation is universal or if different star systems create planets through slightly different processes. The implications extend far beyond just understanding planet formation. This discovery provides crucial information about the early conditions that lead to habitable worlds, helping us understand what makes a planet suitable for life. For example, the amount of silicon monoxide in a protoplanetary disk might determine whether a system forms rocky planets in the habitable zone. Too little SiO, and you get only gas giants. Too much, and planets might form too close to the star. This discovery also validates decades of theoretical work by planetary scientists. Computer models had predicted that SiO condensation should be the first step in rocky planet formation, and now we have direct observational proof. The precision of modern telescopes has reached a point where we can literally watch cosmic chemistry in action. We're not just observing the results of planet formation, we're witnessing the actual chemical reactions that create worlds. Think about the profound implications of this moment. Somewhere in the HOPS 3115 system, the building blocks of potentially habitable worlds are forming right now, following the same processes that created our own Earth. The young star at the center of HOPS 3115 will eventually mature, just like our Sun. Its protoplanetary disk will clear, leaving behind a family of planets that might include worlds capable of supporting life. This discovery represents a fundamental shift in how we study exoplanets. Instead of only finding fully formed planets, we can now observe the actual birth process, giving us unprecedented insights into planetary development. The James Webb Telescope's infrared capabilities were crucial for this discovery. Unlike visible light, infrared radiation can penetrate cosmic dust, allowing us to see into the hearts of protoplanetary disks where planets are born. The ALMA radio telescope array provided complementary data by detecting the specific radio frequencies emitted by SiO molecules. This combination of infrared and radio observations created a complete picture of the formation process. The success of this observation technique means that similar discoveries are likely in the near future. As more powerful telescopes come online, we'll be able to watch planet formation in dozens of star systems simultaneously. The HOPS 315 system is relatively nearby at 1,300 light-years, making it an ideal laboratory for studying planet formation. Its proximity allows for detailed observations that would be impossible with more distant systems. This discovery also has implications for understanding our own solar system's history. By studying planet formation in HOPS 315, we can better understand the conditions that led to Earth's formation and its eventual ability to support life. The research team plans to continue monitoring HOPS 315 over the coming years. They want to track how the SiO crystals evolve and clump together, potentially watching the birth of asteroids and planetesimals in real time. Future observations might even detect the formation of different types of planetary building blocks. Water ice, organic compounds, and metal-rich particles all form under different conditions within protoplanetary disks. The possibility of detecting organic compounds in forming planetary systems is particularly exciting. These carbon-based molecules are essential for life as we know it, and their presence in young systems could indicate the potential for biological evolution. This discovery also raises important questions about the frequency of planet formation. If SiO condensation is happening in HOPS 315, it's likely occurring in countless other star systems throughout the galaxy. The universality of physical laws means that wherever we find similar conditions, young stars with protoplanetary disks, we should expect to find planet formation in progress. The universe is actively creating new worlds all the time. The implications for the search for extraterrestrial life are profound. If planet formation is this common and efficient, the galaxy might be teeming with rocky worlds, some of which could develop conditions suitable for life. This discovery represents a pivotal moment in astronomy, the transition from studying fully formed planets to witnessing their actual birth. It's like the difference between studying ancient fossils and watching evolution happen in real time. The precision required for this detection is staggering. Scientists had to identify the specific spectral signature of SiO among thousands of other chemical signals, like finding a single voice in a cosmic choir. The success of this observation opens up entirely new research possibilities. We can now study how different stellar environments affect planet formation, comparing systems with different masses, ages, and compositions. The HOPS 3115 discovery proves that our solar system's formation wasn't unique or special. The same processes that created Earth are happening throughout the galaxy, suggesting that Earth-like planets might be more common than we thought. This finding also validates the theoretical framework that planetary scientists have developed over decades. Computer models predicted that SiO condensation should be the first step in rocky planet formation, and now we have direct evidence. The combination of the James Webb Telescope and ALMA represents the pinnacle of modern astronomical technology. This success demonstrates how international cooperation in science can lead to breakthrough discoveries. As we continue to study HOPS 315 and similar systems, we're essentially watching the universe manufacture the building blocks of potentially habitable worlds. Every SiO crystal that forms could eventually become part of a planet's crust. This discovery fundamentally changes our perspective on planetary systems. Rather than static arrangements of planets, we now see them as dynamic, evolving structures that are constantly being shaped by ongoing physical processes. The next major milestone will be detecting the formation of larger structures, planetesimals and asteroids, as the SiO crystals continue to clump together. This could happen within the next few years of observation. The HOPS 3115 system has become a cosmic laboratory where we can test our theories about planet formation in real time. Every observation provides new data that refines our understanding of how worlds are born. Think about the profound implications. Right now, as you're watching this video, new worlds are being born in the HOPS 3115 system. The building blocks of potentially habitable planets are condensing from cosmic gas. This discovery represents more than just a scientific achievement. It's a fundamental expansion of human knowledge about our place in the universe. We're no longer just observers of the cosmos, we're witnesses to its ongoing creation. The success of this observation technique promises many more discoveries in the coming years. As our telescopes become more powerful and our analysis techniques improve, we'll uncover more secrets of planetary birth. The HOPS 3115 discovery proves that the universe is far more dynamic and active than we previously imagined. Planet formation isn't a rare, ancient process. It's happening constantly throughout the galaxy. This moment represents a turning point in our understanding of cosmic evolution. We've moved from studying the end products of planet formation to witnessing the actual process in action. So the next time you look up at the night sky, remember that among those distant stars, new worlds are being born right now. The same processes that created our Earth are actively shaping the cosmos. The HOPS 3115 system has given us the ultimate gift, a window into our own cosmic origins and a glimpse of the universe's endless creativity. We're not just studying space, we're watching the birth of worlds. This discovery will be remembered as the moment when humanity first witnessed the birth of planets in real time. It's a milestone that future generations will look back on as a defining moment in astronomical history. What do you think about this incredible discovery? Are you amazed that we can now watch planets being born in real time? Let us know your thoughts in the comments below. We'd love to hear your perspective on this cosmic breakthrough. If you found this discovery as fascinating as we did, make sure to hit that like button and subscribe to stay updated on the latest breakthroughs in astronomy. The universe is full of incredible discoveries waiting to be made. Don't forget to ring the notification bell so you never miss our latest videos about space discoveries and cosmic mysteries. There's so much more to explore in the universe, and we're here to bring you every amazing revelation. Thanks for joining us on this incredible journey to witness the birth of worlds. Keep looking up, keep wondering, and remember, somewhere out there, new planets are being born right now, just like the one we call home.